we look at 12 over 16 and it kind of looks like 2 over 3, so let's test it. What number do we times 3 and 2 by to get 12 and 16? Well, 2 times 6 equals 12, so let's test that. 3 times 6 equals 18. Oh, that doesn't work. Let's test this one here. What do I times 3 by to get 21 and 2 by to get 14? Well, 2 times 7 equals 14, so 3 times 7 equals 21, so that is 1. This is very obvious here. Okay, timesing by 10, 2 times 10 is 20, 3 times 10 is 30, so that is 1. Over here, 3 times 3 equals 9, 2 times 3 equals 6, so that's not an option. And over here, that is, again, an extension of this one. So 3 times 20 equals 60, 2 times 20 equals 40. So these three options are equivalent fractions, these three are not. Question 6 requires us to fill in the gaps. So you're presented with 3 over 5 equals 9 over something, which equals something over 20, which equals something over 35. So we essentially do the same skill as above. Okay, we ask ourselves, well, 3 times what equals 9? Well, 3. So what we do to the top, we have to do to the bottom. 5 times 3 is 15. Okay, so they're now equivalent fractions. We can then do the same thing from the start. 5 times what equals 20? Well, 4. 3 times 4 is 12. Okay, it's harder to go from 9 over 15 to here than here. It's just easiest to start from your lowest common denominator. So 5 times what equals 35? 5, 10, 15, 20, 25, 30, 35, 7. 3 times 7 is 21. So that's all you need to do in question 6. Question 7. You need to write 3 equivalent fractions for each of the following. So we take 5 over 6, and we have to find an equivalent fraction. The easiest, quickest one to do is times by 2. So 5 times 2 is 10, 6 times 2 is 12. And if we're just going to go up logically, we can then go to 3. 5 times 3 is 15, 6 times 3 is 18. 5 times 10 is 50, 6 times 10 is 60. So that is one way we can find equivalent fractions. Let me just draw a small box here to segment that for you. Question 8 is getting us to compare fractions. So is 2 over 3 bigger or 3 over 5? Sorry, is 2 over 3 bigger than 3 over 5? Well, a quick visual always helps me to determine these. It's really hard to tell. So this is where we can multiply to get the denominators the same. So we times that by 5, and this is the skill I was referencing up here, and times this by 3. Okay, so we take the denominator from one side and we multiply both. We then take the denominator from one side and multiply it both over there. What we do to the top, we have to do to the bottom, and likewise. That way we have the same denominator, and then we just read the numerator to see which one is bigger. So 2 times 5 is 10, 3 times 5 is 15, this one over here, 3 times 3 is 9, 5 times 3 is 15. So because of that, I can see that 2 over 3 is bigger than that. This is a great skill, okay, to compare fractions as well as adding, subtracting fractions. Question 9 is something similar, but you just need to insert the symbol to indicate whether it's larger or smaller. So here we have 5 over 8, and we have 3 over 8. So it's giving us the same denominator in the first couple of questions. So 5 over 8 is bigger than 3 over 8. And always come back to year 1, I think I taught it in. The crocodile eats the bigger one. So here's a little crocodile here. It's Kind of looks like a Pac-Man. It eats the bigger ones, so that's how I always remember it. So 5 over 8 is larger than 3 over 8, like that. Question 10 has something similar. I'm getting really tight here, but that's okay. Question 10 says, which fraction is smaller than 5 over 8? So every question relates to 5 over 8. And then it says 7 over 8. So that fraction is not smaller than 5 over 8. That's A. Then it goes on to B, 17 over 24. And here is where we need to break this down. Okay, I can see that 8 is a multiple of 24. Okay, so instead of multiplying, we can divide here. Okay, so it's times 3, so I'm going to divide by 3. Divide by 3 both sides. And that brings it down to 8. 17 divided by 3, well, the closest one there is 18. So 3, 6, 12, 15, 18, which is around about 5. But it's 17, so it's one step down, so it is less. You'd be looking at 4.666 repeater. So it is smaller, okay? That's another skill that you can use. So I might just give you those 10 activities. It shouldn't take you too long. Like I said, if you have any questions relating to a particular question, let me know in Google Classroom and I'll try and answer it as quickly as I can via writing a comment. Otherwise, I can remake a video. For example, this skill here is hard, like it is. You need to practice this a lot to figure it out. And these last kind of questions here will really trip you up, especially some of the last questions. So have a go, see how you feel. Maybe post to me in Google Classroom about how you went today. And we can fix up any mistakes that we made. And I do apologize about the reading. There's going to be lots of reading in today's lesson. Skim through that, look over the examples. Remember, you don't have to do the work examples. And I am sorry about this long video, but I just kind of wanted to go over and really model for you how to do it. I might even write, you don't have to watch the whole video. So good luck.